Hello everyone, my name is Cody De Arkland and I'm with HashiCorp, and I'm here to talk to you a little bit about how we approach delivering infrastructure automation through consistent workflows. It's kind of a mouthful, I know, but we really focus a lot on workflows at HashiCorp, and I want to talk to you a little bit about our approach towards workflows in a DevOps-centric way. Before I dive in too much, I want to start off with this kind of overall concept, and it's this concept that deploying applications is hard. And it's not that the aspect of coding is hard. That's very challenging, and we understand why. I mean, we're building complex systems that talk across data centers, across environments. It's very, very complicated. But deploying applications is hard because of the subsequent tasks that live within that deployment process. It's very complex to take something that lives on someone's laptop and test it, get it ran through multiple different, test, staging, development, production environments, manage the processes at which that executes, manage the different dependencies, and then your internal requirements as well. Oftentimes, it becomes hard because of all of these bolted-on tasks, and in reality, if it was just taking a bunch of files and dropping them onto a web server, that's a pretty straightforward concept. But ultimately, the subsequent tasks and the way that we approach those in kind of the traditional way are what make this a really challenging concept. We see graphics like this pop up from time to time, pretty often in fact, and this generally represents the way applications roll from living on someone's laptop, living on someone's desktop, to getting onto systems that we can access, especially in cloud environments today. We have this concept of pushing code. The developers logged into their system, they're building really powerful things, and they push that code out and it lands onto some sort of a pipeline platform, might be AWS code pipeline in this case. And that pipeline has all of the logic built into it to do stuff with that code. So what does that look like in many cases? It might be just a build process where it's taking it and doing like some sort of a local makefile, or doing building a Docker container, some form of build. Build is a pretty general term here. Taking it, building it, and then releasing it. And ultimately, release could mean very different things based on those different environments. If it's going to testing, release could mean very different than going to production. And the point of me talking about this slide in the context of this presentation is that each of these tasks, it's really easy to capture this on a single slide and show it in front of people and say, hey, this is your deployment process. But anybody who does this on a daily basis knows that there's a ton of steps that live inside of this that you never see, because ultimately build, I kind of hit on it when I was running through my quick example. What is build ultimately? Is building a Docker container? Is it an npm up? Is it an npm build? Is it npm? Is it some other form of like an abstract thing? Is it a makefile? Like, it could be anything. And ultimately, that complexity lives in what build is. Same thing goes to release. What does release mean to you as a customer in your environment? Does release mean that it's tested? Does release mean that it's available to a subset of people? That test concept oftentimes gets lumped into release. Release is a very broad term. So ultimately, this is why deploying applications is hard, is because there's a lot of stuff that happens in here. And ultimately, at the end of the day, it's down to people. It's down to me and you sitting at these keyboards doing this work. And ultimately, the way that we do them ends up being different in a lot of ways. Not to say I'm right or you're right. It just means that there's differences. And these different tasks are open to a certain level of interpretation at times, even if they're run booked out. So we know that when we deploy these applications, when we're taking systems from local development on a laptop into production, there are these common pitfalls that exist inside of this space. We have the concept of inconsistencies that exist. And I kind of hinted at this when I was talking about you and me as administrators working on these platforms, building these things and deploying them out to AWS in this case. Ultimately, the way that I interact with the AWS console or my AWS tool set is going to be likely slightly different from the way that you do it. And this is a pitfall because it creates an inconsistency in the environment, or not necessarily in the environment, but in the process at which we deliver this. What if objectively your process is faster than mine? You're able to deploy quicker, deploy more consistent in an environment because the task set that you operate off of is very different from mine. So inconsistencies pop up, not just from a technology stack perspective, but in the people that operate these platforms. Beyond that, we have this concept of mandatory processes. We've all worked in environments where there were these processes that were absolutely had to be followed in any way, shape, or form. And oftentimes we have a different way of getting to the point where those mandatory processes are implemented. So these pitfalls exist because they add complexity to the overall process. These mandatory processes, it might be very short and simple to accomplish a task, but that mandatory process makes it a lot more complex because you have to factor in maybe things like compliance requirements, things like security concerns, just different things that your business operates on and requires. And anyone who's worked in enterprise technology loves this one. The way we've always done things, we're in very fast changing times, and technology has jumped forward so drastically in really the past five years that it's easy to fall into, not for any negative reason, but just the way we used to do things, the way we've always done them, the way these processes have always been built, the way these servers were always deployed. And now I want to take that server process and do the same thing in AWS. And it doesn't always work out that well. And it creates a lot of challenges. And ultimately, as the slide says, pitfalls that people fall into. We have to look at things as technology evolves, our processes need to evolve too, and the way that we approach these problems needs to evolve at the same rate of change that the technology has changed. So if you look at how you did things 5 years ago, it should be very different today based on the drastic changes to the technology that's happened inside of that same window. So again, thinking about takeaway from this slide is just there are pitfalls that we all deal with on a day-to-day basis in our environments and the way that we work inside of these tools. And our ultimate goal should be to find ways to avoid falling into those pitfalls anymore. So it makes you think, as you take a step back through all of this, is there a better way? And better is kind of a funny phrase, because what is better, right? Is better to me the same thing as better to you? For me, better might be more hands-off. The system runs itself, and I'm handling kind of orchestration. Better to you might be more increased stability. It might be factors that are very metrics driven. Neither one of us might be wrong in that case. Think, well, in reality, more stable systems are better. But ultimately, better is a bad phrase. What if there's a faster way? I think of a lot of financial services institutions where they need to make changes in a stable way, very quickly, in order to drive their business. So maybe better is actually faster. Can we do this any faster? Can we deliver these systems in a stable and safe way, in a quicker way? I tend to default to simpler. I think that you can have a process be complicated in what it actually accomplishes, but the process itself is simple. The way that you operate the tool, or the way that the system deploys, or the way it's managed is simpler. So I tend to default to preferring a simpler way to accomplish these tasks. But think about yourself as you're listening to this. Think about what is that to you? What is better to you? What is better in your environment, and how can you achieve that? Taking a step back, there are common challenges we see in this DevOps space. And DevOps is a little bit of a loaded term, but when I think about DevOps, I think about taking the concepts that development teams have taught us around the way they deliver software, the way they deliver technology to consumers. And how do we apply that to the way we deliver systems, the way we deploy applications as operators and infrastructure and engineers? So some of the common challenges that exist in this space. I think about the infrastructure needed. And this slide is a little bit off because ultimately it's not just about infrastructure. I think of this more actually as resources that are needed. If I'm deploying into AWS, I need to worry about a Route 53 DNS entry as well. That is a resource. And while it's not an infrastructure per se, I'm not standing up a server just to give me a Route 53 address, but it is a resource that's needed. So thinking about the resources that are needed in an environment as you start to lay out your kind of pathway to taking this into production. I think about secrets management a lot, right? The way these systems communicate between each other. How are we managing that in a central way that's scalable? How do we have a system that allows us to interact with that, integrate with that, and pull that content out and use it between these different tiers? So I think about that management of secrets as another challenge that comes up quite a bit in our conversations. How do we actually have this system be a common place for all of the secrets between different systems inside of my environment? I think about connectivity a lot. How do I actually have these systems connect in a consistent way? In the age of virtual machines and Kubernetes and Docker and serverless, things get very complicated to connect to one another. Ultimately, it's all just networking on the back end, but these platforms use networking in a little bit of different ways. So how can I create a consistent way of connecting these systems together? And how can I take a policy-driven approach that allows me to apply security in that same consistent way between all of those systems? And finally, we're talking about living inside of AWS in this case. We're talking about deploying workloads and deploying applications, but we ultimately need a technology for these to land onto. How do we actually have a platform that runs these systems, makes sure they stay running, makes sure they're running consistently, has safeguards in it for me doing canary deployments, blue-green deployments, has me set up to be able to actually effectively run these. And we think about these kind of four pillars, four verticals as challenges we see very often in that DevOps space. And ultimately, it leads us to a place where, like, why we created this cloud operating model. And you hear us talk about this cloud operating model quite a bit. And it's really, it's a recipe for how we manage, run, deploy, connect, provision these systems in a cloud environment, in a cloud-first way. Because going back to what I said before around the ways management has changed over the years and the way that we deal with technology has changed, we can't operate with that same data center-centric operating model. We need an operating model that's born in the cloud that understands the agility that's needed to move at that pace. So in order to deliver these applications or these application workloads consistently, that cloud operating model needs to be in place. And we do this through a few of our products, obviously, that handle an individual tower each. So looking at the runtime layer, that concept of where is this going to run, that idea of running using Nomad to do that, to control the way that systems run, to schedule and orchestrate the running state of those systems. Console from a networking standpoint, how do we connect those systems together? How do we apply a consistent security policy between those? And how do we control the flow of traffic as it moves between a Kubernetes environment back to an EC2 instance, and then back into something like a Docker container or a Fargate instance, something like that. While those are connecting, how are we securing that connectivity between those things? Not from a certificates perspective, although Vault can do that as well, but thinking about the actual credentials that are passed between these systems. How do we ensure that those secrets are being rotated at a consistent basis? How do we have that be kind of the central store that systems can come into and pull that secret data out and integrate into? And none of this would be possible without the infrastructure that runs underneath and the resources that live underneath that that actually have the workloads land onto them. So using Terraform to control that infrastructure and get those resources that we need inside of an environment. So stepping through those kind of in reverse order, when we talk about Terraform, we think about Terraform as this single control plane for cloud provisioning. And provisioning, again, we're used to this concept in enterprise IT of provisioning systems is always how we click the buttons that have a VM pop up or have a serverless function be running or have a Kubernetes cluster land in front of us. But ultimately, cloud provisioning is a broad term. There's a number of things you need to provision in order for a Kubernetes cluster to come up. And using Terraform as that single control plane to manage that, give visibility to that, and ultimately drive collaboration between teams. If I go out on vacation, you can go and see the Terraform manifests that I've been deploying, modify them as needed for the next project, and deploy it again. You can see the previous runs as they're happening or as they've ran historically, and determine if something went wrong or understand the status of where that deployment is actually at. So Terraform gives you that single control plane for cloud provisioning, and I think that's one of, again, we're going through 4 of these. It's such a major thing to have that visibility and that collaboration place to be able to drive resource provisioning. Going back to what we talked about around Vault, this idea of the single control plane for cloud-based security. We think about that in the context of certs, as I mentioned before, not specifically in this conversation and talking more about secrets, but certs, again, as a common way to deliver these, like, a consistent security model between systems that oftentimes aren't very consistent between one another. Having Vault be that thing that all of these can tap into to pull secrets data, automatically rotate them, and deliver that agility from a security-focused mindset. Consul holds a special little place in my heart since I spend most of my time talking about Consul, but thinking about the way that we create connectivity between, again, systems that oftentimes has very different ways of connecting with themselves and each other as is. Some of the powers that come in when you start to use Consul as that single control plane for cloud networking is you have the single place where you can control the flow of traffic as well. So how do I gradually roll out these new services? How do I create failure scenarios or failover scenarios between a cluster living in one region or a cluster living in another region? And Consul gives us that ability to control that traffic flow, but also implement things like zero trust security around leveraging something called intentions to allow or disallow communication. So So console has a very big part to play in how we connect these environments together. How do we drive the automatic discovery of applications and make those applications available for developers to consume? And finally, talking about Nomad as a single orchestration engine for the cloud. And orchestration is another broad term. When I think about orchestration, I think about how do I ensure systems are running? How do I ensure that they're available? How do I ensure when something goes wrong that they come back up and come back to life? And ultimately, how do I ensure that different types of runtimes are able to stay consistently running? It's not always a Docker container. Sometimes it's a local process. Sometimes it's a batch job. It could be a number of different things. And using Nomad as an engine for controlling that orchestration state and being able to have it operate as that single control plane for cloud orchestration is a very powerful thing when you look at how we create consistency amongst inconsistent things in an environment. And ultimately, when you take all of these four things together, you get that cloud operating model you get the technology side, I should say, of the cloud operating model where traffic flows all the way through this. The infrastructure is provisioned, it's secured between services from a credential standpoint with Vault. Its traffic is managed. The policies are applied for allowing disallowing communication as well as traffic splitting between those services on console. And then ultimately, it's kept running using Nomad. And we see this model being replicated amongst a number of customers. I'm not going to read through all of these unless you've had enough slides coming at you over the course of reInvent so far. But we had a number of customers who take this approach, and not everyone jumps in and takes all of these at once. Oftentimes, they start with low-hanging fruit, and they start to solve problems, and they start to step through where those workflow challenges are, and they bring these four tools together at the end to drive kind of an end-to-end story of how they can take an application from living on someone's laptop to running in production, scheduled, safe across multiple regions and environments. So we talked a lot about our existing products, our existing story, but we've had a couple of new products release very recently, and that's a Boundary and Waypoint. So Boundary is something that gives us a secure access to resources that are deployed. So how do I simplify the way I connect to systems that I've deployed out into my environment in a secure and kind of centralized way? Waypoint, on the other hand, the first one was Boundary. The second one, Waypoint, is so I talked a lot about the idea of deploying workloads and onto systems, but how do I handle that deploy part, right? How do I take a workload that lives, or an application that lives locally or lives in a Git repository? How do I handle the build, deploy, and release parts of that application? How do I tie into that cloud operating model and have like this a single tool be able to drive that actual application build, having it drive that maybe the Docker container build, and having it push out to Kubernetes onto Nomad? How do I have it integrate in with console? And Waypoint is the thing that drives that. It's a consistent workflow tool for build, deploy, and release applications on any of the platforms that developers commonly use today. And ultimately, going through all of these things, we talked about kind of a lot of broader concepts, but I like to talk a lot about outcomes and how does this approach deliver outcomes? Like, what are we actually doing to get those outcomes and get us into a place where these kind of benefits are being realized? I think that we talk a lot about infrastructure as code at HashiCorp, and to me, infrastructure as code gives us a mechanism for both collaboration. It gives us a mechanism for creating repeatability. How do I ensure that the way I'm doing this is consistent with the way everybody else on my team? How do I set the pace at which we can do things? If I'm going to deploy out, a multi-Kubernetes cluster application on EKS, and integrate it with virtual machines and have console control the traffic between these and Vault manage secrets, how do I have a consistent way of doing that entire stack approach? And taking an infrastructure as code approach gives us that opportunity. When I think about the way code lives in something like Git, and having that main.tf file for Terraform that lives alongside it that is the running definition of the infrastructure that needs to be deployed. And I've got that Nomad job file that says, hey, here's once this infrastructure is done and once this application is available, here's the actual running state. How I control that this thing is actually running the right way. When I've got console dictating the security policy, and I can see that in code. In each one of these products, I can see the configuration file it's not only easy for me to interact with that and change that as needed, but it's also easy for me to take that and replicate it for the next project. So I'm spending less time trying to figure out how to do this. I'm taking known success patterns and applying them the same way to the next project. Or again, if I need to change an existing project, I'm not hunting and pecking for a new way to accomplish an existing task. I'm going in and editing these files and reapplying them. And the system is looking at it and saying, hey, what's changed? And delivering that. Optimally, I'm doing that in like Terraform Cloud, where I'm applying these console configuration changes as part of a Terraform manifest that's then being driven through Terraform Cloud, just as an example. And all of this stuff gives you that baseline, right? When we have this stuff running in full speed, you have that now baseline of your running environment. You have that baseline of the way your environment is set up to operate, the way people are going to re-provision this when things go wrong, and ultimately the way you can take this and template it for the next run down the road. That's all I have for you today. I really hope you enjoyed hanging out with us. Go ahead and take a look at many of our console, Terraform, Nomad, and Vault.io pages. And I hope you have a great reInvent. Have a great day.